In this video, we're going to continue our discussion of concavity and curve sketching, but we're going to focus on just the second derivative test for local extrema, and we're going to look at an example of how you should use that. So, we're using the second derivative test for relative extrema to find our local maximums and or minimums. So what we're going to do is we're going to start by just taking the derivative of the function that we have. So y prime would be 3x squared minus 3. Now, I want to find my critical points, just like I would normally do. So I'm going to set this equal to 0. Going to notice that I could factor out a 3. Now, this is not the only way to solve this. You could just get the x squared term by itself. Then I notice that x squared minus 1 is a difference of squares, so that would factor as x minus 1, x plus 1. So setting each part of this equal to 0, my critical points are 1 and negative 1. Now, normally we would have taken our derivative and made a sign chart to find our relative or local maximums and minimums. But the second derivative test says, hey, once you take your derivative and critical points, take the second derivative, which in this case would be 6x, and see what happens at those critical points. So if I substitute in 1, I get 6, which is a positive number, but our second derivative test for relative extrema says if you have a critical point and the second derivative is positive at that critical point, then that is your relative min. So I now know that I have a relative min at x equals 1. Now, if I wanted to know the y value, I would go back and substitute in and get the y. And to do that, if I put 1 into my original equation, I'm going to get 1 cubed would be 1, minus 3 and plus 5. 1 minus 3 would be negative 2, plus 5 would be 3. So my relative min occurs at the point 1, 3. Now let's see what happens when I use my other critical point, which was negative 1. Well, if I do 6 times, using my second derivative, 6 times negative 1, I get negative 6, which is negative. And my second derivative test for extrema says if you substitute in a critical point and get a negative value, that's where your relative max occurs. So I have a relative max at negative 1. And then we can go back, substitute in negative 1 into my original equation. I'm going to get negative 1 cubed would be negative 1, minus 3 times negative 1, which would be plus 3, and then plus 5. So negative 1 plus 3 would be 2, and 2 plus 5 would be 7. And now I know my relative min and my relative max. So these are actually very quick ways to test for local maxes and mins if you don't want to have to do a sign chart. So you can just use your second derivative, evaluate. If you have a positive value for your second derivative, it's your relative min. And if you have a negative value for your second derivative, you have a relative max. Again, I just want to reiterate, you have to use your critical points to check for relative extrema. You can't just pick any point that you want and substitute in and get your relative max or min. It has to be your critical points.